Let's do, what we can do when we got something complicated like this is to think about different numbers and what they would be if I actually plotted different points, and that way I can get an idea of what's going on. So let's think about what this function does. This greatest is called the greatest integer function, and you basically truncate. Those of you who code may know what I mean when I say truncate. No? Okay. Not doing that. Okay. That may be old school stuff. I don't know. Truncate is to chop something, chop it off. So like if I have the integer 1, for instance, this thing is asking me to write the integer that's either, if it's equal to what's inside of here, to write that integer. If it's got a decimal on it, you're going to chop it off, okay? And just keep the integer part. Basically, that's what this function does. It pretty much just chops it off. So you're always just wanting the integer it's either equal to or the one less than it. Write down from it, okay? So, for instance, if I had 1, x equal 1, there would be a point at 1, 1, because 1's an integer, so I'm going to use its value. If I had x is 1.1, it would still be 1. If I had x, and it's supposed to be straight, and of course I got off right. If x is 1.5, I would chop off the 0.5 and make it 1. If x is 1.9, I would chop off the 0.9. I'm not rounding here, I'm truncating, which means chopping it off, okay? So it would go, at 1, it would go all the way here, but once I hit 2, it would jump up to here, okay? What I'm graphing now is the parent function, not quite 51 yet, because I'm going to use the parent function to graph everything else quickly, because I don't want to have to think about this too much, because my head will start hurting if I have to chop it off and then do all kinds of stuff to it. So at 2.1, it's still going to be on that line, but at 2.9, it'll still be on that line. But what happens at 3? 2.5 would chop off to 2, 2.6 would chop off to 2, 2.9 would chop off to 2, but at 3, now it's a new integer, right? So I'm going to go up here at 3, and I'm going to color it in. And what's going to happen there is until I get to 4, you know, 3.1, 3.2, 3.3, through 3.9, and anything in between is going to chop off to 3. But when I get to 4, I'll go up again. Do you see the pattern here? This is called a step function. Do you see why it's called a step function now? If I'm at 0, it's going to, if I have 0.2, it's still going to chop off to 0, because you could write it 0.2, right? So if I'm at 0.5, it's still going to be 0 because it's 0.5. 0.9 would still be 0. But when I get to 1, that's when it jumped up here, and that's where we actually started today. So what you could do if you want to draw this is you see the pattern now. So instead of thinking about it all and giving yourself a headache, you do this. You know, you just continue the pattern, because it's going to work the same way with negative integers, okay? So now your problem, this is the parent function, this is the greatest integer function. And it's the greatest integer less than or equal to the number. I'll put that down here too. What if I want to graph 51 now? What's the only difference between my parent function and this function? This right here. Doesn't that number, when you add or subtract a number on that end, isn't that a vertical shift? It's going to bump the whole thing up 2 spots up. So if I graph my parent function, and what you might want to do on these problems is use one graph and just use some different colors if you got some matte pencils or highlighters or something that you could grab, or markers, and use. If I want to graph f of x is equal to the greatest integer function plus 2, all I got to do is take each dot that I've graphed and move it up 2. So this one right here would go 1, 2. It's now here, but it's colored in. And so it's going to come like that, right? Because I haven't stretched it out or anything. This one would go 1, 2. It would be here. And it's going to go to the next integer and be open at that end. This one right here would go up 2. Make a big dot because I know I'm accidentally making dots, just counting with the stylus. and it would go here. And now I can see the pattern, right? I know what's happening here, so I could just go, okay, it's just everything got scooted up to. So the next one would be here. And you don't have to graph every little piece of this, just enough that you get the idea. I could even come down here and do, there's going to be one here if I want to have one over in the negatives. So we just took and did everything right one, so you just took the red ones and moved them to the right one. Okay, so I'm going to go ahead and label my axis here. I'm going to put the Y up here in case I need to go up further. I may need to, so I'll extend it in case I do. Ooh, that's not good either. Okay, so let's start with the first one. If I have x less than 0, isn't that telling me for all negative numbers, basically, I'm supposed to graph x plus 3? What I do with these, sometimes it's easier to graph the whole thing and then erase, graph it lightly and then erase the part you don't need. That's how I go about doing stuff like this, because otherwise it can get more difficult, I think. You can always graph by plugging points in if you want to, but x plus 3, if we look at that, let me write that over here, y equal x plus 3. Doesn't that have a y-intercept of 3? And what's the slope on that one? This is just a regular line. Where's the slope? It's in front of the x, so it's the slope of 1. So if I go to graph this, if I have a y-intercept of 3, 1, 2, 3. Now, I'm going to be careful here because it's hard for me to erase on my iPad. It just does these big bubble things, and it's not easy. I notice that x has got to be less than 0 when I graph this. So my y-intercept of 3, normally I would draw a little, and you might on your paper draw a little, just a dot there, because you can erase real easy with a pencil. But I know since x is less than 0, that's right at x equals 0. At x equals 0, I have a different equation to use, I think. No, that was x less than or equal to 0, wasn't it? I didn't copy, or it didn't catch when I wrote it. Actually, that's going to be a colored in point here. Now, the easiest way to graph this is to go up 1 over 1, right? Couldn't I then just extend that line? On your paper, I would connect those 2 points. You know you're going to stop at x is 0, right? Because you're only graphing this equation for x is 0. So, I mean, you could draw the whole line in, but if you do, you end up, I'm just going to draw the part I need. I'm going to kind of just think, okay, I'm going through that point. That's what ends up on my paper. I could have just drawn the whole line with something straight like a ruler or whatever you got. Edge of your calculator is what I use sometimes when I'm doing it, if I don't have something handy. But I know that I only want it for 0 and less, so if I drew the whole line, I would just then go erase that top part. That's how I do it when I'm actually graphing on paper. It's just easier to do it that way. Okay, so does everybody okay with what we've done so far? That makes sense? Okay, so when x is between 0 and 2, it says just, you could think of it this way if you want to write, instead of writing f of x, y equals 3. Isn't that just a horizontal line through 3? Do I want it for all numbers, though? Do I want to draw a big old horizontal line through 3 for the whole graph? If I did, it'd be okay, because I could erase the parts I don't need, and it might help me get it graphed easier. So that's the thing I like doing. But between 0 and 2 is really all I need of it, so I could just graph between 0 and 2. And is it equal to 2? Is there a line under that equal sign on that? Yeah. 0 less than x less than or equal to 2. Okay, so since there's the equal sign by the 2, that means I'm going to color in that dot at the 2, and there's the horizontal line at 3. You can't really tell where this one breaks because, what was that?
The book's just fell out.
Oh, it's okay. Yeah, look, you can see how the Algebra 2 and pre-algebra students did their books yesterday. I mean, Tuesday looks great, doesn't it? Okay, so usually when I would have ended this first one that I drew, there would have been an open line there, and then I would go, somewhere else and draw that dot and pick up with my graph. It's just that they kind of end and start on the same place, and it's the same, 0, 3. This graph here that I just drew would have had an open circle, but it was colored in from the first equation. Okay, so now for I can't even read that. For x is bigger than 2, it's 2x minus 1. Okay, so what would my y-intercept be there? Y equal 2x minus 1. Negative 1. Now, am I going to count that point? No, but if I drew it, I'm going to go ahead and draw it here, and I'll try to erase it in a minute, okay? If I draw it there, even though I don't want to pick up until I get to x is equal to 2, and even at x equal 2, isn't that going to be an open dot for this one? Because if you're trying to find the value at x equal 2, that's on that middle one, f of x equal 3, correct? Because that's where that tells you to use that graph when x is 2. But if x is bigger than 2, 2 is my boundary point. When I draw this line, I'm going to draw an open circle wherever this graph hits at 2, and then keep going with this one. So if I graph 2x minus 1, keeping all that in mind, it starts at negative 1, and the slope is 2 over 1, right? So up 2, 2 over 1. I'm not going to count that point either. Up 2 over 1. Oh, look where it landed. It would have been an open dot there, but it actually just happens to land on that end point. And most of the time that doesn't always happen. It just does in this problem. So I can kind of tell that my line needs to go like this. Let me see if I can draw it. Let me see if I can undo that now. Okay, that button's not working. And I could just extend it on out, and then I'll use a red to show where I would erase. I would erase that because that's not on my graph. I would erase all this at that point. And so I end up with a graph that looks like this. And it's a lot easier on paper if you're using a pencil to do this and then erase the pieces you don't need. A lot of times you'll have graphs that look like, let's see on the next page, I think they show some, no. Sometimes you'll have graphs that look like this, you know, it might, this is just another example, this is not 47, but it may look like this, and then come up here and do that, and then stop there, and then maybe down here it picks up and it goes like that or something, you know. So the thing that happened here was just that these points ended up colored in because they just happened to, you know, lay on top of each other when we graphed them. So the red, again, not really part of the deal here, just showing you what sometimes things look like.